In this video, we're going to talk about density calculations. In the last video, you talked about mass, volume, and density, and what they basically were. You did mass and you talked about the units, you talked about the volume and density. So in this one, we're going to talk about calculations. First of all, density. You'll hear density by definition is the mass divided by volume of an object. Mass divided by volume. Okay? The mass divided by volume. Now, typically, your density is going to be in grams per milliliter. Why? Because grams are easy to measure in the laboratory, and milliliters are easy to measure in the laboratory. Most of the equipment in the laboratory, graduated cylinders, things like that, are going to be in milliliters. Grams, you can easily put that on a scale or a digital scale. Grams per milliliter give you density. So, star, make sure you write this off to the corner somewhere. Okay, actually I'm going to do that on here because we're going to use it here in a minute. The density of water, pure water, is 1.0 grams per milliliter. Okay, so the density of water is 1. It's exactly 1. Okay, so if you want to drop something into water, if you have a density that is greater than 1.0, it sinks. If you have a density that is less than 1.0, it floats. Okay? And so you can compare things and see if they will float. Now, we're not always dealing with water. If you're dealing with things that are, if you work for a refinery that's making gasoline and oils, you need to know how much the oil and gasoline, will they float in one another? You've probably seen movies where they will have water and it has gasoline on the top and they light it on fire and somebody's swimming under it. How can they do that? Because the density of gasoline is less than water. So when they light it on fire, the fire's on top of the water or the oil, diesel, whatever it is that they're going to use for it, and so you're safe as long as you stay underwater. One of my ex-students is a stuntman in Hollywood, and he was talking about he's done multiple of those stunts where as long as you can hold your breath and keep swimming, you're safe because it floats on top of the water. So let's do calculations with density. Okay, so let's say that an object has a mass, and I'm going to do this as a word problem on purpose because this is typically how you'll see it. An object has a mass of 425 grams and a volume of 367 milliliters. What's its density? Give you a second to write that down. If I ever get ahead of you, just pause the video, write it down, and then hit play again. Make sure you do all the calculations with me. Very first thing you want to always do, now this is huge, huge in chemistry class. We're going to get all kinds of formulas during the year. Start with the formula. Density equals mass divided by volume. Write the formula and then literally put the numbers where they go. An object has a mass of 425 grams, so I'm going to write that right where it goes, 425 grams, and a volume of 367 milliliters. Now, first thing I need to check, if density is in grams per milliliter, do I have grams? Yes. Do I have milliliters? Yes. Then I'm ready to calculate it. The calculator work is always the last thing that you do. So I'm going to take my handy dandy calculator. 425 divided by 367 equals 1.158038. Okay, so I'm going to write all that for now. 1.158038147 grams per milliliter. That's everything on my calculator. Now, we're going to apply what we've learned in the past. Is this the answer? There's no way. And the reason is I look at these numbers and there's no way that this can be the answer if these are the numbers we started with. So we just learned how to do sig figs in the last few days and rounding. So this is multiplication and division. So what was the rule? Least sig figs. How many sig figs does that number right there have? Top number has 3, and the bottom number also has 3. So how many am I going to put in my answer? 3. Start at the front of the number. 1, 2, 3. Stop the number. Does this make it round? Yes. So the answer, the exact answer to this question is 1.16 grams per milliliter. That's the answer. You'd box it in. If this was a question on a test or a worksheet, you would have gotten it correct. If you wrote all of that, that would be wrong. If you wrote 1.15, that would be wrong. You didn't round correctly. So where you cut it off, the next digit, if it's 5 or above, makes only the next one round up. It's pretty simple. And we've done lots of that. Okay? Example number 2. I'm going to use the same background, but I'm just going to take out the numbers. So I'm going to show you a fast way to take notes when you do this, but I'm going to go ahead and write the question first. Okay? An object has a mass of 16.42 grams, and milliliters is going to be 24.1 milliliters. Now, what I would do in my notes is I would not write that whole question again. In my notes, if I were you, I'd write example 2 because it looks the same. And then I would steal the numbers out of the question. An object has a mass, so I would put mass, this is what I do in my notes, 16.42 grams, and a volume of 24.1 milliliters. That's all I need to write. I don't need to write an object has a mass of. Why? I already have those words in the first example. Okay, so I would steal this out and then I'd work the problem. Start with the formula. Remember what I said a while ago, we're going to have lots of formulas in this class. Start with the correct formula and plug the numbers that you're given. If the mass is 16.42 grams and the volume is 24.1 milliliters, is it in grams per milliliter? Yes, grams milliliters. So I solved the problem by taking my calculator. 16.42 divided by 24.1. My calculator says 0.6813278. Okay? Round correctly. How many sig figs? 1, 2, 3, 4 sig figs. 1, 2, 3. You go with the least. Zeros don't count. That's a placeholder. Remember that? First real number, 1, 2, 3. Stop it right there. Does the 3 make that round? Nope. So I take out the rest of the number. It's all gone. Grams per milliliter, and box that in. So on the first question I had 1.16 grams per milliliter, and on this one I had this. Okay, so here's a very typical question. Those would be the right answers. Those are the exact answers. So this had 4 sig figs, that had 3, this has 3 sig figs in it, this one, okay, we have the answers. So the question is, sometimes they'll refer back and say, look at this object right here. Will it sink or float in water? Well, compare that to the density of water. If water is 1.0 grams per milliliter, the units have to be the same. That's greater, so what does it do? It sinks. Yeah, that would sink. This one is less than 1, so this object would float. So the object that had that mass and that volume, that would actually float. That would be like a piece of cork. Okay? That would float, or like a ping pong ball. Okay? So it would float in water. All right? So those are pretty easy. It's not very difficult. You plug the numbers in and you solve. Now, sometimes we have to use what we know to get what we don't know. So let me explain. Example number 3, and you'll want to write this out. And I'm just going to say an object again has a density of 2.1 grams per milliliter and a volume of 623 milliliters. What's its mass? Give you a second to write that down. Pause if I get ahead of you. So I have 2 of the 3 numbers. So I'm going to take density equals mass divided by volume. Start with the formula. Write down what they gave me. They give me hint words. It has a density of 2.1 grams per milliliter. So they gave me that. And a volume of 623 milliliters. My unknown is this. Now, in math class, they use an X. Now, I had a student a few years ago, they're like, I don't like doing algebra, I don't know, I don't like X, I don't really like it. That's fine. Then we can make it a smiley face, but it doesn't really matter. We don't know that answer, okay? So I'm going to use an X because it's from algebra. Some of us like math. And the problem is, you have to remember how to do this. This is from Algebra 1. And I know it's not add or subtract, do I multiply or do I divide? Well, here's the shortcut. If I'm correct, if I put that over 1, that doesn't change anything. And so, most important thing I'm about to say is right here. Do you see that? Milliliters. That has milliliters. They have to match. Those are matching units. That's awesome. So that means, what is the units going to be on this when I get the answer? It's going to be in grams. Why? I have matching milliliters, so that means grams has to match it. So how do I solve this algebraically? So fraction equals fraction, I cross multiply. 1 times x is equal to x. And that number times that number gives me a number, so all I need, I need my calculator. So I grab my calculator, 2.1 times 623. I get 1,308, 1,308.3. There it is on my calculator so you can see it. Okay, is that the exact answer? Well, sig figs. 2 sig figs, 3 sig figs. So I'm going to go 2. 1, 2. Cut off my number. Oh, this is a fun one. Okay, does the 0 make it round? Nope. Now this is a tricky one that sometimes gets people, so we're going to cut off the rest of the number, right? But look, I have a decimal. Now if this was money, this would be $1,308. Does that round to $13? No. But I got to get to at least to the decimal, so I need placeholders. What do I put as placeholders? Zeros. Now, how many sig figs in this number? There are 1, 2, placeholder, placeholder. Do I put the decimal? No, putting the decimal makes those significant. I just need 1, 2 of them. This is the exact answer. Okay? That's the best I can do with my answer. Why? This one is really specific, but this one isn't. Now, I can check my work to see if I'm right. Here's what I mean. If 1,300 grams was this answer, now I rounded a little bit, but if I take that divided by that, what do you think it probably equals? Something close to that. So let's see. 1,300 divided by 623 equals 2.08. See it? 2.08. That's about 2.1. Why is it off? I had to round a little bit. That's my real answer, but if I took the answer that was on the calculator, yeah, okay, I got the answer. I can check my work. I can know if I'm doing it correctly. Okay? So what if a question on this one, you did all this math and they said, would this object sink or float in water? Wow, look at that number. That number doesn't matter. What do we know about water? Its density is 1.0. Well, they told us the density is 2.1. Well, I automatically know it sinks in water because that's greater than 1. So don't make the questions any harder than they are. They're pretty easy to work out. You just plug the numbers in and solve. Okay? So I'm going to take this same question and I'm going to manipulate it. I'm going to use that same number and I'm going to change it. Here's my question now. An object has a density of 2.1 and a mass of 47. Let's make that a better 7. 47.2. What's its volume? Okay? Density equals mass divided by volume. Okay? Plug the numbers where they go. Density, 2.1 grams per milliliter. All right. That means something's got to be in grams and something's in milliliters. Yep, 47.2 grams. My X this time is down here. And so I've got to solve. By the way, it's going to be milliliters. Did you figure out why? Matching grams means that milliliters is going to be my answer. And so put this over 1 and I'm going to cross multiply. So the math looks like this. 2.1 times x is 2.1x. And 47.2 times 1 is 47.2. In algebra class, leave the x there. How do I move that over? It's multiplying right now, so I divide by 2.1 so it's gone. Oh, okay, so if I just take those two numbers, 47.2 divided by 2.1 equals, got an answer of 22.4761904, and I ran out of room. Okay, 22, you can see it on the screen. Okay, great. So is that the answer? Well, no. 2 sig figs, so let me give you a hint. There's numbers everywhere. How do I know what to count? Use the numbers in the question for the sig figs. 2 sig figs, 3 sig figs, so I go with 2. 1, 2, stop. Does the 4 make it round? Nope, it's done. 22 milliliters is the best answer I've got. Okay, based on the numbers they gave me. But Mr. Kelly, I see the 7 would make that become a 5 and then it would round. Remember, you only look at the place right after. Does it make it round? Nope. And that's it. Okay? Now again, I could check my work, 47.2 divided by 22, I'm going to be pretty close to this. I know that's the answer, and it's in the right units. Okay? It's really not too hard. Now I'm going to give you a hard question. Okay? All right, I'm going to give you a difficult question. So I'm going to put this, and if it were me, I'd put a star in it, and this is how I do it all year long. If I have a star, okay, make some note in your, something in your notes that really tell you, okay, that's a hard question. Okay? So I'm going to use this. An object has a density of 2.1 grams per milliliter and a mass of 1.6 kilograms. What's its volume? Okay, and you probably already saw it as I wrote it out. Density equals mass divided by volume. This is applying the skills that I told you a few days ago you've got to be able to do, and it's not too hard. Plug the numbers in. Let's see, an object has a density of 2.1 grams per milliliter. Got it. So that means something's in grams, something's in milliliters. It's not. So what do? We'll fix it. Okay, so 1.6 kilograms. I need it to be in grams so that it matches the density. Okay, that's fine. Remember this from the other day? Make your words go away first. What word goes here? Kilograms. Yeah. And when you're in the metric system, you always run to the base. So if it's kilograms, you're going to run to grams. And by the way, that's the unit you want. Awesome. Words are gone. Who's bigger, kilogram or gram? Kilogram. Look on the chart and you will see that kilogram on that chart. In your notes, flip back a couple of pages and you will see that kilo is 1 times 10 to the third. 10 to the third is 1,000. Okay? So take your calculator, 1.6 times 1,000 is 1,600. Okay? 1,600 what? Grams. So here's the best way to do this. 1,600 grams. I'm going to keep that. That was 1.6 kilograms. Wrong. 1,600 grams. See what I did? I wrote the number they gave me, but I put the number I have to use. Now I'm ready to solve it. Now, put this over 1, cross multiply. There's my x. Now, if it gets too busy for you, really mark that out so it goes away so you don't make a mistake. Cross multiply, so it's 2.1 times x, those two guys, equals 1,600 times 1. Keep the x right there by dividing by 2.1. Moves it over there. So 1,600 divided by 2.1 equals 761.9047619. That's a really long number. Check me on your calculator. Okay? And so I'll go back to the original question. How many sig figs there? 2. How many sig figs there? 2. 1, 2, stop. 760. What units? I have matching grams. So that means it has to be milliliters. There's my answer. So the only difference between, quote, a hard question and a normal question is if they don't give it to you in the right units, if it's not in grams per milliliter, then you just convert one. Let me show you the other one real quick. What if it's not the grams? What if it's the milliliters? Okay? And I'm just using the same question just to make life easier. Okay? And this one's going to have a volume of 1.34 liters, and I want to know the mass. Okay, so density equals mass divided by volume. Okay, so I'm going to plug the numbers in, 2.1 grams per milliliter. Now, let me just give you a hint. Whenever you have a density, okay, these are the units you want everybody else in, because it's really hard with 2 units here to change that number. Now, every once in a while you're going to see something like this, 1.3 kilograms per liter. That is a density. If you read a question that said not grams per milliliter but kilograms per liter, then somebody's in kilograms, somebody's in liters to work your problem. So that means your mass would be in kilograms and your volume would be liters. Okay, so you make this and this match the units of what you see in the question. Okay, so in this one, grams per milliliter. So I need to have a grams. Well, that's mass. Well, that's the x. I don't know that. And milliliters. I don't have milliliters. So 1.34 liters. Liters, make the word go away, becomes milliliters. Who's bigger? Okay, liters are gone. Who's bigger? Liters. And if you look at your chart back a couple of pages, you'll see that that's 1,000 also. So multiplying by 1,000 moves your decimal 3 places, so that becomes 1,340 milliliters. Am I done? No, all I did was convert this. I made this a number I need, 1,340 milliliters. See that? That was the number I was given, but I couldn't use it. So I turned it into what I need. Okay? Just for space, I'm going to erase this. Okay? Put it over 1, cross multiply. X equals, oh, just multiply those two. Don't guess. Every year I have students, they're like, this number and this number I divide, or this number and this number I multiply. Try to memorize that. Put it in the formula and you know every time. You don't have to memorize. 2.1 times that. So 2.1 times 1,340 is 2,814 exactly. What units? Well, I have matching milliliters. That means it's in grams. Okay? And so, look at my numbers. How many sig figs? 2. How many sig figs? 3. I'm going to go 1, 2. Oh man, decimal's way out there. So it's 2,800 grams. That would be my answer, right? See how I did that? So 2 sig figs, 3 sig figs, 1, 2, cut it off. But I have to have my placeholders in. That would be the answer. Here's the trick. You'll get this. What if the question had said, okay, I've got an object with this density and this, the math's all the same, but they wanted the mass in kilograms. Okay, then I wouldn't do that. I would say, first of all, it has to be grams. They match, right? Milliliters match milliliters. This is grams. I worked the problem. Grams, got it. But they want kilograms. That's fine. Then what I'm going to do is I'm going to take that 2,814 grams and just change the grams to kilograms. Who's bigger? Kilograms. And we saw in the last one that that's 1,000. So let me do that again. Grams go away to kilograms. Since kilograms bigger, he's number 1. And so I look up on the chart and kilo has 10 to the third. 10 times 10 times 10 is 1,000. So in this case you divide by 1,000, moves your decimal back 3 places. 2.814 kilograms. Got it? So it's now in the units they wanted. I'm just playing with units. The question is this the exact answer? How do I know? Sig figs. 2 sig figs, 3 sig figs. 1, 2, stop. The answer is 2.8 kilograms. It's not a very good 8. 2.8 kilograms. And so when you solve these problems, always write the equation. Put the numbers where they go. Match your units when you plug them in and solve. Read the questions carefully. Most of these problems, it's not difficult. It's just reading. In the next thing you're going to do, you're going to practice some of these on your own.